The next autofocus method to discuss is laser-based autofocus, which is a great option, particularly for fluorescence, because it does not require a high contrast image from the camera in order to work. So in this case, we're actually bouncing an IR laser off of the cover glass of the sample, and we're collecting an image of that laser spot on a camera, on an autofocus camera, and we're simply, there we are, and we're simply identifying the centroid of that spot. So if I go ahead and start live and focus, you can see that that spot position actually changes with focus. In fact, I can even hit contrast autofocus, and we can watch the spot move with automatic adjustment based on contrast, just as an example. So in order to use this feature, it's pretty straightforward despite the numerous controls. So the real controls we need to worry about are to start and stop live in order to get our spot. And we want to make sure we have a nice Gaussian spot somewhere in the field. We can change the brightness of that spot through the exposure of the camera, the autofocus camera. And finally, once we have a spot that we're happy with, we just need to hit initialize. So initialize will move the focus through a set range. It'll generate a calibration curve that ties the position of this spot with the focus of the camera, with the focus of the microscope in microns. So you'll see at the bottom here, once calibration is complete, that we have a correlation of 1.022 microns per, this is the centroid of this dot in pixels. So if this moves by a pixel, we move by about a micron or so. So once this is all set up and initialized, let me go back to live here. And you can see we're a little bit off focus. I now, under laser autofocus, have the option of setting reference. So let me set a better focus here, and I'm just using the Z knob to set focus. Maybe I'm happy with that. And if I set reference, now I have a reference distance, again, between the objective and the cover glass.